Hello everyone and welcome back to Complete Frontend. This is Shrikant. In this channel, I teach people the most advanced concepts and I make them simple and easy to understand. In this lecture, we are going to be learning about stack and heap. So as a computer science individual, you're expected to know these concepts. These are the most fundamental concepts of a programming language and how a programming language or an application works on your computer. So in this video, we are going to dive deep into stacks and heaps. I hope you're ready. If you have a notebook and a pen, I would highly suggest take it out because I'm going to give some useful tips. You want to write it down. Okay, so let's start the lecture. So what is a stack? So stack is something that is fast to access. So when you take out a memory, so for example, if you take out this memory as the RAM of your computer, it will have multiple partitions. So it will have something called as the data component, it will have the stack component, it will have the heap component. Don't worry. I will explain each one of this in detail in this lecture. So essentially what you can understand about this is that your memory is divided into different segments. You can understand it like a PG, a paying guest, you know that, right? So where there are separate rooms for each person. So you might have your own individual room, that room belongs to you. Similarly, your friend or your PG mate can have another room for themselves, right? So there are space allocations for different person over there. Similarly, in the memory as well, you have stack and heap memory and they're used for different purposes. Just like different people live in those different rooms, here different purposes will use these different kinds of memories. So let's understand that. So when you run your program, what actually happens? For example, there is a function. Let's say there is something called as a function. Okay. If you're new to function and you don't know what function is like that chunk of code that has a certain task to be done. For example, you have a calculator application. Okay. And there are multiple methods over there like add, subtract, divide, and multiply. Right? So you can imagine this add to be one small segment of task that can be done within a function. So this is a function for you, this is a function for you, this is a function, this is a function. All these are called again inside of another function. So that is how you can imagine functions. Okay, I'm not going to get deep into functions in this lecture. There will be a separate lecture in the JavaScript playlist for that. So you can tune into the complete JavaScript playlist and understand about that. So when a function or a task is put into the stack, so there is something called as a stack. Okay, so that is called as LIFO. What is LIFO? Last in, first out. What is a stack then? So let me explain you that. This can be called as a stack. Getting it? So there is this book, above that there is another book, above that there is another book, and there is another book. Now if I want to, if this is kept on the floor like this, if I want to take out this book, the middle book, without making any other book fall or touching them, is it possible? Kind of not possible, right? So this book has to be kept down first, then this book has to be kept down, then I can take this book out, right? So that is what a stack is. A stack is nothing but one thing kept on top of other, and that becomes a stack like this. It's a stack of books over here. Similarly, there is a stack of tasks in your programming language. So here there will be one task that is doing something. That task will say, hey, I need another person's help. That will say, I'll need another person's help. That will say, I need one more thing. Okay, so this guy is somehow calling this, or this guy is somehow calling this, and but this has to be going out for this to go out, then to this to go out, then to this to go out, right? That is what a stack is. Now every stack has something called as the stack pointer. Okay, so nothing but a stack pointer, that is a pointer pointing to different stacks over here, saying, hey, this is number 1, this is number 2, this is number 3, this is number 4, and so on. Okay, so there are stack pointers for each of these stacks. Pause. So there are stack pointers pointing to each of the tasks or these blocks over here. Now stack usually is used when a program is running. Only when a program is running. Essentially your application is running and you need memory for that application to run, right? So that is where stack comes into picture. Okay, stack does not have too much memory. Stack usually has somewhere between 0.5 MB to 1 MB. Okay, you can write this down. What is the ideal size of a stack? That is just 0.5 MB to 1 MB. What are stored in the stacks then? We'll get to that, but you can understand that this stack is very small. It is not a big chunk of memory. Okay, but it is very quick to access. Stack is nothing but a contiguous set of memories. Write it down. Contiguous set of memories. Contiguous set of memory means in the memory, like I showed you previously in the previous lecture over here, this stack will always have this continuous set of memories. It won't be here, then here, then here. That will never happen. Okay. So stack will always be a contiguous set of memory. Got it? So it is small in size and it is very quick to access because there is a pointer pointing to it, and you can quickly go to where is the current stack trace going on, what is going on over here, and I just need to go to that particular point. So stack is amazingly quick. So what will be stored in the stack, like we were discussing? You can think of local variables will be stored in the stack. Any function calls that may be called, that function calls inside the function there will be other variables, right? So what do I mean by that? So if you don't know functions, just listen to me. You don't need to worry about this. This is how you write a function in JavaScript. Okay, you can say function add, and it takes two parameters, say n1 and n2, and then it just says sum. So for example, let sum is equal to n1 plus n2. Now, how many parameters are there? This is what is called as a parameter. The function takes two things to be able to actually perform that task. Imagine a parameter for a car to run is petrol or tires, right? All these things are parameters for a car to be able to run, or for an engine to be able to run, you need that petrol and oil, right? For a car. Similarly, function needs the parameters to be able to run. There are functions that may not have parameters as well. Let's get to that again in the next functions lecture. Here you can think of this sum is one variable that is called as a local variable. Local variable means as soon as this function is done, this variable also disappears. So what the computer will do is it will delete that. Why? Because stack is thrown off from this stack trace. Okay, this thread essentially. Every stack is created for every thread. So if you know already the concept of thread, you will understand this. If you don't understand, you will understand that in the future lectures, but you can understand it like it is a set of actions that happen in a particular order. Okay, so it's like one engine in a train. So you might have seen this goods trains, right? Goods train you might have seen. Now there is an engine pulling that train, right? There can be two engines, one engine at the back and one engine at the front also. When there is too much load or too much work to be done, there can be one engine at the front, one engine at the back pushing it, another will be pulling it, right? So you can think of both of them as threads. They're doing two different things. One is pushing it, one is pulling it. Similarly, when a program has multiple things going on there, it might have multiple threads, okay? And every thread will have this stack going on, okay? You can imagine it like that. Essentially, you can understand it is one set of one engine that can do any number of tasks in the order it gets. Okay, that is what you can imagine as a thread for now in a very simplistic format. Okay, so these local variables will be stored in this stack, and this stack memory is contiguous, and what is going to happen is it's going to store this simple variables inside of that at some places. Okay, but what about the stack frame? That is what this is itself is called as the stack frame. Everything that is happening inside of that is nothing but the stack frame. We already discussed about the stack pointer, and we already discussed about total size and last in first out also. We also discussed about functions and variables. Local variables will be stored inside of the stack memory. Now what is stack overflow? Now say that this set of books that I have is kept inside of a box. Okay, this much big box only. Okay, this big of a box will be kept. Now if I put more things on top of this, like if I put my phone on top of this, then I put my mouse on top of this, then I put my hair comb on top of this, and I keep on putting the things inside of this, what's going to happen? At one point it's going to fall down outside of the box, right? Correct? So that is nothing but stack overflow. So when does this happen in a programming language? Whenever there are so many tasks happening together. If you know recursion, you might already know this. When there is a recursion without an exit statement is one of the things. If you don't know, don't worry about it. You can just understand that when there are so many tasks happening one on top of the other, and before removing the last task, so many tasks are again coming on top of it, what's going to happen? It's going to overflow. Imagine it like there is a bucket of water and there is a pipe at the bottom of this bucket. Okay, so you can imagine it like this. Essentially, this is your bucket of water. Okay, and there is a tap here on the bottom. As the tasks are done, this is going out. Okay, but the water keeps pouring at a faster capacity. Now what's going to happen? Your bucket is going to overflow. Similar things. Okay, you can imagine this to be exactly the same way. Got it? So that is what is your stack overflow is. So stack is small in size and stack overflow can happen. So we need to be careful while working with stacks. Do not store things in stack that does not belong there. Like, do not store large amount of data inside of the stack. Obviously, your programming engine, your JavaScript engine is smart enough to decide what should go into the heap and what should go into the stack. Now, is it persistent memory? No, it is not gonna be, it is gonna, so essentially what I mean by persistent memory is this variable that is inside of this function, if I want to call it in another function, say subtract, okay? Now you may not be able to do it, okay? You may not be able to do it because as soon as this function is done executing, this is gonna be removed from your stack, okay? Like I was showing you, it is gonna be removed from your stack. The moment the variables, the function call, whatever is happening inside of this function, this will be totally removed, okay, cleaned up. Got it? So you can't have something that you need across your calculator. For example, you want to have a result, save it in your calculator. So some calculators have this save function, and you want to use that in another subtract or multiply. Not going to happen. It should not stay in the stack. So where should it be stored? Now that is what is coming, right? That is where your Mr. Heap is coming up. Okay, Mr. Heap. Don't call it Mr. Heap in an interview. It's just a set of memory that is large enough. For example, heap is a significant, it can be, it doesn't have a proper size. It's not like 0.5 MB, 1 MB. It will dynamically increase and decrease. So the memory for heap has dynamic allocation. So it can dynamically increase and decrease depending on what? For example, in your computer, you are running your YouTube app, you are running your browser, you are also running your program, you are also using VS Code, you are also watching a movie, you are also editing something, you are also, for example, opening a PDF file. So many things happening, right? All of them have to be stored somewhere, right? If so many applications are running, all those applications will have separate threads, and they will be running. They will be all taking the memory from this RAM itself, your RAM itself. So if you know the RAM, you might have come across things where you would have seen things like, computer gets suddenly slow. Have you seen that happen? So when you're doing so many things in your computer becomes slow. Then what do? You go and find out certain applications and delete them, right? Have you experienced this? I hope you have. So that is where your RAM is coming into picture, and your heap is derived out of the RAM itself. So what is the limitation for heap? That is your computer's memory. Your computer's memory is the limitation for your heap, but it can dynamically allocate and deallocate the memory based on its needs. Got it? Now, what is the duration of the heap? How long will your heap be available across the lifetime of your project? So when you want to store something that is going to be used in multiple functions or throughout your application for multiple things, those will go into the heap. So how can you imagine the heap? Okay, you can imagine the heap to be this big set of memory. Imagine this to be your complete memory, and as you assign and allocate and deallocate your memory, it's going to get assigned over here. Okay, now why is this important for you? You see, at one point in time, this can become full. So as new variables come in and they're allocated and deallocated, there will be space. So these small chunks are utilized. Imagine that whatever I'm scratching through is utilized. This is not utilized. Okay, this guy is not utilized. For example, this guy is not utilized. This is not utilized, not utilized, not utilized. Similarly, so on will be there. Okay. Now, why this was not utilized over here? This was not utilized at this point because at some point something was assigned here, then it was removed in the course of the program. Okay. Now, this is an empty space over here. Imagine this space to be of size 2, this to be of size 2, this to be of size 2, this to be of size 2. Just taking random 2 MB, 2 KB, think whatever you want. Okay. Now, I have a bigger chunk coming in which is of 8. Okay. Now, together here 4, right? 2 plus 2 plus 2 plus 2, I have 4. Imagine this is not existing right now. This is completely occupied, you can think. Now there is 8, but can it be stored? No, it cannot be stored. This is the problem with heap. The thing is, even if there is space, if it is not contiguous for something big, it won't be able to be stored. Quick example for you. Say you're trying to book a movie in Book My Show. You and your 3 friends are trying to book it. So you 4 people are trying to go. Obviously you want to sit together and you want 4 contiguous seats. But in that movie, it was the peak hour and almost all tickets are booked. Only 4 tickets are remaining, but they're at 4 different places. Can it fit you? No. You guys want to sit together. There are 4 seats, but you still can't sit together, right? Same thing. I hope you understand that with an example now. Now moving forward, the next topic. Who manages the heap? It is managed by your operating system. So if you're using a Windows laptop, your Windows is managing it. If you're using an Apple MacBook, your Apple laptop is managing it. Okay. So whichever is your operating system is managing your heap memory. Okay. So this is also done. Let's go to the next topic. So is it faster or slower? We discussed that stack is super fast, right? It is small in size and it is super fast. What about the heap? Heap is going to be slower. Why? Because it is a big chunk of memory, and in that big chunk of memory, you will need to manage it also. So it is dynamically allocated, like I told you, right? So it needs to go and find where it's actually present. Let me help you understand this with an example. Say in your class, all of you people are sitting according to the roll number. Okay. Now, if you know that from the first bench, roll number 1 to roll number 50 is going to be sitting after one bench after the other, you can, if 5 people per bench are present, you know that for example, the 12th row number person will be in the 3rd bench. Agreed? But if they're randomly sitting, you will now go and search where your person is sitting, right? Because you can't deterministically imagine where this person is sitting. That is why heap is harder to find. You can imagine this heap to be like this randomly sitting people versus stack to be organized. Okay, that is why heap is slower and your stack is faster. Now the next topic is computer memory limitation, right? So what is the computer memory limitation here? So as I said, the dynamic allocation happens in heap. Okay, that means the memory is automatically allocated as and when required, or it can expand or shrink based on the requirement in the heap. Okay, like in the stack, there is a limitation, right? Like in stack, it can only be 0.5 MB to 1 MB. If it goes beyond that, then what is going to happen? It's going to say the stack overflow error, right? So in the heap, that's not the case. So only limitation here is your computer's memory, your computer's RAM. Like I was telling you, you could be running a lot of applications together. Like I told you previously in this lecture, right? You could have YouTube open, the browser open, any number of applications open, and they all consume the same memory. The RAM is limited. RAM is not going to be expanded, right? So the computer memory limitation is the limitation for your heap memory. Now coming to fragmentation. Fragmentation is something that I already discussed over here. This itself is fragmentation. So there will be smaller chunks of memory that will be stuck in the middle that probably can or cannot be used. Right? So there is 4 memory slots over here that are present. They cannot be used unless that size of memory or something that is lesser than the space available here is present. Like I was giving you the example of Book My Show, if you remember earlier, right? So the seats may not be available. If there is only one person coming for the movie, he probably won't care. He can sit anywhere. But when 4 people as friends group, they come into the movie, they probably expect to sit together. You're getting me, right? So that's about the memory fragmentation. So the next thing is memory leaks. let's understand what memory leaks are. So there are two kinds of variables that are assigned in the bucket, like I told you, right? So like in the previous lecture, I was telling you about how so like I was telling you in the previous lecture, I was telling you about how there are racks of memories present over here, right? And now this memory has certain things assigned to it. There are two kinds. So I was telling you about this in the previous lecture as well. So probably I will quickly reiterate for those who are new. So I can save a friend's number directly into my mobile phone, right? So let's say 9434 something like this, right? Now, or I can say, hey, the number is stored in this page number 10, page number 10 in some book, and I can just remember this page number 10, and then I can go find that person's number in that page number in some book, right? There is one other thing there, that is directly accessing the value or accessing the reference. So it is called as call by value, call by reference in functions. Okay, so it is nothing but directly taking the value versus taking the reference. So telling that, hey, the page number 10 has the number is calling the reference. The page number 10 has the reference to the actual value, whereas directly going and saving it in my mobile number and getting the value of it is nothing but directly taking the value. Getting it? So now in the heap, there could be any number of data structures stored, like it could be an object, an array, or anything. Okay, so now, am I directly taking the value from there, or am I taking the reference? Right? So sometimes what happens, like I told you, in another memory location, like if you haven't watched this, I would highly suggest you to go and watch the memory lecture that I did yesterday about how variables, going in depth in variables. It is lecture number 9 in the JavaScript playlist. You can go there. I will link it somewhere in this corner or that corner of this video, and you can check it out. Okay, but what I'm trying to tell you is there can be situations where there will be references stored to the actual value. Okay, now it creates something called as a pointer to that reference location. So imagine it like this: you have a house, it is person, let's call him Mr. A, okay, and there is another person, Mr. B, who knows the prime minister. Let's just assume. So now I know Mr. A, Mr. A knows Mr. B, and then he knows the prime minister. So I don't have any contact with Mr. B, I know only Mr. A. So Mr. A has the reference. So whenever I want something from the PM, I can just say, hey, I know that you know the PM very well. Can you help me get this or something like that, right? So just like I'm just giving you an example over here. Okay. So you tell Mr. A. So Mr. A is referencing to this person, okay, who actually has direct contact to the PM. Getting it? What a reference is. But if this Mr. A, if he directly knew PM, then this is just directly calling the value. The value here is the PM. Okay. So now what would happen when a memory location is pointing to another memory location? Coming back to the previous point over here, there is something called as garbage collection. So whenever there is an array stored or any other object stored in the heap and it is not required anymore, garbage collector is a person who actually comes up over there and cleans it up. Garbage collector is an algorithm. I'm going to make a separate lecture for it in the future. So in the JavaScript series, you can go and check out in the future. You will find a detailed lecture on exactly how garbage collector works under the hood. But for now, you can know that garbage collector is something that will clean up this dangling pointers, or it could be something that is not using anymore. What is a dangling pointer? There could be a pointer that is pointing to an object, but that object is no more present. So you can imagine it like this. There is a small auditorium and there are seat numbers present over here. You know that in seat number 5, your friend Shravan was sitting. Okay. And this was told to your friend A, and friend A knows that somebody important is sitting in seat number 5. Shravan gets up from this seat and he leaves the auditorium. Now, you still think that Shravan is sitting in this auditorium. This is your pointer, and that pointer is called as a dangling pointer. It's nothing but it doesn't actually have the value anymore. It previously had a value, but garbage collector just came and cleaned it up. It's like Shravan did something stupid over here and they kicked him out of the auditorium. Okay. Now that it's similar to like how variables, its work is done, so it's kicked out. Okay. So, but you still think he's sitting in seat number 5, but that is not the case. So this reference becomes a dangling pointer. Got it? Now dangling pointer is also done. We have learned about almost everything that we need to know about what are pointers and references. So one more thing about pointers is if a pointer is referencing to some value, and then if it is not cleaned up, because now you're thinking that Shravan is still sitting in seat number 5, and now this person A's job, let's say, is to send people to free seats. Okay, whichever seat is free. Shravan was removed from this seat, but person A doesn't know that he was removed from the seat. He still thinks 5 is there. So this 5 seat number, nobody gets assigned to this seat number 5. Similarly, in this memory as well, what is going to happen is if that reference is still present to a memory location, then no other variable will be assigned there. So this memory is always stuck. So now that means when you're opening multiple applications, it actually thinks that that memory is not empty. Okay, it could actually be a stale data over there. That means a data that is not required anymore, or a data is maybe even removed from there. Got it? So then what happens? Then that memory is stuck for no use. Even though there is space, it would feel like there is not enough space for other programs to execute. Got it? So just like in this seat number 5, if somebody else is now standing in the corner of the auditorium, but they could have actually come and sat there. Got it? That is all about the heap memory over here. I think we learned mostly about it. Now let's get to the memory layout. This is the last important topic of this lecture. So let's get through that. So I showed you how memory addresses could be 01 into 000F, 02 into 0001, something like this, right? So as this number increases, it is called as a higher address. And as this, for example, if this is the starting memory, it is called as a lower address. Okay. So to ensure that stack and heap don't collide with each other, a stack always starts with higher addresses, while a heap always starts with lower addresses. So what is this text segment? Text segment is nothing but your compiled code. Once you write code, if you don't know what is compilation, don't worry about it. You will learn what is compilation in the future lectures, but just know that there is something called as compilation that happens in a program. That compiled code, that text segment, will be stored in this text segment. If there is any variable or data that needs to be stored, that will be stored in this data segment. Okay, then comes your heap that we just discussed about. Similarly, there is a control stack and there is a data stack, essentially combining to the stack. That comes from the higher address. The higher address and the lower address, they keep going up. As that data is not required anymore, it could be removed and they could free up space and go back up, and this could go back down. But if there is a high usage, then this could come down and this high heap and this could meet. Okay, at that point you will get a complete memory out. Your system will run out of memory and your PC could completely freeze or it could crash. Okay, this is how the memory layout happens in a program and in a computer. I hope this is clear. Okay, so this is where they travel up and down. Okay, this is the space where they will be traveling up and down. Got it? So that is about what is a memory layout. One other thing I would like to tell about the memory is objects, arrays, and anything that is a global variable will be stored in the heap. Anything that is a local variable that is required only in the scope of the function will be stored in the stack. I hope this is clear to you. If you have any doubts in this lecture, I know this lecture was a bit complicated. This is an advanced lecture. If this is a bit hard for you to understand, if you're a beginner to coding, get back to this video after you complete more lectures in JavaScript. Okay, once we reach like 30, 40, 50 lectures, you watch all those and then get back to this lecture. If you're a person who already knows a programming language and is trying to learn JavaScript right now, I'm pretty sure you would have understood this. If you still have any doubts, put your doubts in the comment section below. I'm happy to answer your doubts. or you can go to t.me, okay, slash complete front end. Okay, complete front end. You can just watch that link in my bio of this channel itself, or just search for @ complete front end in Telegram. There is a channel where I give updates, and there is also a group over there that is pinned to that channel where you can join and directly chat with me. Okay, so either you can use the comment section of this video, or you can use that chat or follow that channel, and I'm happy to clear your doubts. I hope you enjoyed this lecture. I'll see you in the next one. Thanks for watching Complete Front End.